This is a variable acceleration question from one of the CCEA past papers. This one's from June 2019. It's obviously the A2 applied one, and it's question 3. The velocity of v of a particle travelling in a straight line at time t is given by this. The particle is instantaneously at rest on 2 different occasions. Find the times whenever the particle is at rest. It's obviously at rest whenever v equals 0. Supposed to be a v, sorry. So we would go 2t squared minus 9t plus 4 equals 0 and solve the quadratic. Quadratics, I hope you know how to solve. A couple of different ways of getting there, but you should be able to end up with 2t minus 1t minus 4. That means 2t minus 1 is 0, or t minus 4 is 0. And that means time is a half and time is 4. So it says it's instantaneous rest on 2 different occasions, and those then are our 2 different occasions. Part 2, find the acceleration of the particle whenever t equals 3. Obviously our acceleration is given then by dv by dt, so we need to differentiate then the v formula. So let's go back. It's reasonably straightforward. Differentiating this, 2 times a 4, so 4t minus 9. And we want to work it out then whenever t is 3. A is 4 upon 3 minus 9. And that gives us then 3 meters per second squared. Part 3, find the total distance covered by the particle in the first 5 seconds. Part 1 is useful for us in that scenario because it tells us when it was rest, so it's probably backed onto itself here, so we just need to be careful of that. However, to work out our s, we need to work out the integral of v. So it's going to be the integral of, what's my v formula? 2t squared minus 9t plus 4 dt. So that gives me 2 over 3t cubed minus 9 over 2t squared plus 4t plus c. Let's see if it gives us any information at the start, but I think we can see if they say our c is 0. Given the time t is instantaneous rest 2 different occasions, find the time as a particle at rest. Cs. So we have it set up here. Whenever time is 0, it is at 0. So because that will give us the distance travelled then from 0 to 5. So that means when t is 0, s equals 0, and that gives us c is 0. So we can safely assume then our formula is 2 over 3 t cubed minus 9 over 2 t squared plus 4t. We want to know in the first 5 seconds, and so things kind of change around then after half a second and after 4 seconds, so we need to work those out. So we want to work out where this particle is whenever t is 0, whenever t is a half, whenever t is 4, and whenever t is 5. Whenever t is 0, that's easy, sub in 0 in there, we're going to get s equals 0. I'm not going to do this bit for you, but hopefully it'll make sense. We're going to sub in a half in instead then of this to work out where it is, and we get there 23 over 24. Whenever t is 4, so exchange my t then for a 4, its displacement is minus 13 1/3, and whenever t is 5, its displacement is minus 9 1/6. So a thing that people mistake all the time is to put in 0, to put in 5, and to think, right, it started here, and then after 5 seconds it's here, so it's travelled 9 1/6 meters backwards. That's not correct, because it's gone forward first, and then backwards, and then back in itself. So we just need to try and work out what's happened here. So it's all travelling effectively along a wee kind of timeline here, and at time is 0, it's at 0. Whenever time is a half, it's at 23 over 24. That's just shy of the number 1, obviously. Whenever time is 4, it's gone then back to here, so it's minus 13 1/3. And then whenever time is 5, it's at minus 9 and a sixth. So can you see what's happened? It's quite confusing. It's gone from here to here after half a second. Then after 4 seconds, it's ended up here. And then it's finally ended up here. So the distance travelled, we need to go from here to here, plus here to here, plus here to here, and that will work that out our distance. So let's work out what we're doing. From here to here is going to be 23 over 24, plus that's going to be 23 over 20. To get from here to here, so after from a half, the thing is 23 over 24 plus 13 and a third. I hope we're good with that. So you can just put that in your calculator. To get then, so that's from there to there, then from there to there is that, and then from here to here, it's going to be 13 and a third, take away 9 and a sixth. If you put that into your calculator, you will get 19 and 5/12 meters.